The group is not fast, just furious, with Decamp, Waye, and Andrew Dorsey, and our project is an academic stress and health monitor. So for our official problem statement, the real problem is that college students are experiencing hazardous mental and physical stress due to their academic environments. And we set out to design an improved smartphone system that identifies if mental stress is being experienced through a questionnaire using a button response, and to evaluate physical health through a pulse sensor. The smartphone system will output a message about possible risk on an LCD corresponding to information collected about the individual. For our two background research articles, the prevalence and correlates of depression, anxiety, and stress in a sample of college students, and the university stress scale measuring domains and extent of stress in university students, it is discussed that the highest contributors to stress reported stemmed from academically related topics for college students. Within our market research, we identified the pulse sensor technology developed by Fitbit to measure the heart rate of users. This technology depends upon using a green light, which is then absorbed by blood and then tracks the volume changes of blood flowing. Although this device collects physical data, it doesn't collect any mental data, and that is what our project is aiming to do, is to both evaluate the physical and mental components using the questionnaire and pulse sensor. Here is the first of our SolidWorks drawings, with the two top images being side panels of the acrylic box, the bottom left being the top part and the bottom right being the bottom. Here are the other two sides of the box with holes cut out for the cable.
This is our project that takes in pulse monitor data and responses to survey questions to output whether a user is at risk of too high a level of mental stress. What will happen is, based on your responses to how frequently you've been bothered by these following problems, you'll get a sum, and if that sum is over a certain number, it will decide you're at risk. Or if your pulse rate is above a certain number, then you're also at risk. So whether you get one or the other, it will automatically display it before you finished both. But if neither are true, then it will say no risk. So I'm going to do this from the perspective first of someone who's at risk based on their survey responses, and then from the perspective of someone who is at no risk. So, how often over the past 2 weeks have I felt nervous, anxious, or on edge? I'll say nearly every day. Not being able to stop or control worrying, nearly every day. Worrying too much about different things, more than half the days. Trouble relaxing, nearly every day. Being so restless that it's hard to sit still, more than half the days. Becoming easily annoyed, nearly every day. Feeling afraid as if something awful might happen, more than half the days. And then I'll go to take my pulse rate data, and even though it didn't get a response yet, it's going to display at risk because my survey responses were too high anyway. And then it will output this tune for the person who has been at risk of mental stress. Now I can reset it with this small gray button, and the LCD clears, and this time I'll respond for someone who hasn't experienced these problems very often. So I'll say, not at all feeling nervous. Not being able to stop worrying, I'll say several days. Worrying too much, not at all. Trouble relaxing, not at all. Being so restless, several days. Becoming easily annoyed, not at all. Feeling afraid, not at all. And then I'll go and I'll take my heart rate data this time and wait for it to get a number. Okay. And when I release, that will be the number that it held. My heart rate was below a certain BPM and my survey responses were below a certain sum, so I have no risk and no tune plays. So what the serial monitor is displaying is all the BPMs that our pulse sensor is calculating, whereas what our LCD is going to be displaying to the user is the BPMs that are in a certain normal range. That would mean that it's not just an error. So we have it set to within 40 and 140 beats per minute, whereas our serial monitor here is just showing any BPM that is calculated in the code. So our two inputs are these buttons and our pulse sensor. These buttons are used to calculate the sum based on the survey questions. This one is what you hold down so that we can intake pulse sensor data. This is our reset button. Our two outputs are the LCD screen that will display the BPM of the user and whether or not they're at risk, and we have our speaker that will play a song if the user is at risk.
This is the pseudocode that our group used to program in Arduino. We started by setting up the library for the LCD and declaring the pins where the pulse sensor and the buttons would go, along with the speaker. We made a variable for the real BPM, meaning that it would store the values that are in a normal range from 40 to 140. We made a function for the song that would play after the result showed at risk. We chose a song for release. In the setup, we made sure that the LCD starts cleared, the serial monitor is open, and the buttons are declared as inputs, and the speaker is an output. In the continuous loop, we allowed the buttons to intake data. We added the sum from the survey questions, and when the small white button is held, the pulse sensor is allowed to stream in the raw data and shown in the serial monitor. It sends the real BPM to the LCD to output the value, and when the button is released, it would show at risk or no risk depending on the survey questions and heart rate, and a song would play if the heart rate was over 100 or if the sum was over 15. This is our real Arduino code. We started by loading all of the libraries that are needed from SparkFun. And we used our resources to learn how to use the pulse sensor as well as the buttons and the speaker, which is a buzzer here name. We learned how to control the speaker by changing the duration of a tone and what frequency the tone is at. The buttons were all set as inputs, and here, depending on which button is pressed, it adds to the sum of the survey. We customized the upper and lower thresholds for the pulse sensor data, and were able to filter it so that it only read the values that were from 40 to 140. And as the small white button is pressed, it controls the output, whether it's at risk or no risk, depending on a heart rate over 100 or a sum over 15. And here you can see that we called our song function if the user is at risk to play the tune from the top. This is our bill of materials showing all the pieces that we used in our project. We have a breadboard and a breadboard. We have 4 different colored buttons along with 2 mini buttons, an LCD, a speaker, and acrylic for our laser cut pieces. We have a pulse sensor, a battery, many wires and bridges, and a small breadboard to fit the buttons up against the top of the box. We used foam board to practice the box, and then we have a potentiometer for the LCD's brightness. Our project successfully intakes information from the user through a questionnaire and pulse sensor, and uses the data to determine whether the user is at risk for potential adverse health consequences. We learned a lot about the engineering design process, from idea to final product. We found that working as a team helped us work efficiently and allowed us to check each other's work. We are very proud of our product and how much progress we've made over the year.